everyone, you're welcome back to Explore Insights. In today's video, I want to teach you on how to convert octal number system to binary number system. Now, in this scenario, I will go along with 3 to 4 examples. What am I going to consider? I'm going to consider the value without decimal points and with decimal points. Please, if you are just joining this channel for the first time, please do well to subscribe to this channel. And look out for our subsequent video where I have covered number system conversion. So without any further ado, let's get started. So the first thing I want to relate to us is we're talking about octal to binary. And if we were to represent octal in binary, it's simply 2 to the power of 3. Now, with that, I'm going to come up with something which is octal and binary. Now, we can relate that octal, which is 2 raised to the power 3, in this scenario, it's going to have its highest value to be in the power of 2. What do I mean? We're just going to have 2 raised to the power 2, 2 raised to the power 1, and 2 raised to the power 0. Having an idea with this will help us know the right calculation to do given any question based on the conversion of octal to binary. In our previous video, I made mention that if we have the value 8, it means it will run between 0 to 7, and 7 here is the highest digit. So let's put that down. In a simple form, 2 raised to the power 2 will represent 4, 2 raised to the power 1 will represent 2, 2 raised to the power 0 will be 1. Now, if we sum this total, it's actually representing the 7, which will be the highest digit. So let me put down different values that occurs in octal number, which is 0 to 7. So we have 0, 1, 2, 3, 4, 5, 6, 7. Now, this is just a simple trick. All we have to do is to visualize and then tell what could be the result. If we want to find 0 within this value, it becomes impossible because 0 doesn't exist. So to that, we are going to put 0, 0. Now, if I'm to locate 1 within this, it can be seen that 1 is found here. It means 4 and 2, I'm going to put 0, 0, and 1 will be here. Let me say it in other ways. What can represent 2 here? It means we have exactly 2 in this case. So my 4 will be 0, my 1 will be 0, but my 2 will be on as 1. What about 3? If we have 4, 2, 1, what will sum up to give us 3? Definitely 2 plus 1 will give us 3. So it means my 4 will be 0, 2 will be on, and 1 will be on. So guess about 4. If I take the 4 to locate within here, exactly the same 4 we have. So we have 1 here, while 2 and 1 will be 0. If we are to locate for 5, what will be the sum up for 5? Definitely it's going to be 4 and 1. So the 4 and 1 will be turned on, but the 2 will be off. So therefore we have 1, 0, 1. The same manner we go for 6. What will be summed up to get 6? So please take note, I'm using this. What will be summed up? So it means 4 plus 2 will be 6. So I'm using 4 and 2, but not 1. So 1 will be 0. And lastly, let's go for 7. For 7, how can we achieve 7? It will be the summation of the 3 of them, which is 4 plus 2 plus 1, which will give us 7. So at the end of the day, we'll have 1, 1, 1. So this will be the key in helping us solve examples in this video. So with that, let's quickly look at example 1. Now, if we are given to convert 7, 1 in base 8 to binary, we are asked to find x. What do we do? So the first thing I'm going to do is to bring out this value 7 and 1. Like I previously said, 8 and 2 is like 2 raised to power 3, which is the relationship in binary. Now, I'm going to take these 3 for the digits to represent a set. What do I mean? It means that I'm going to consider 4, 2, 1 in this scenario. So we are going to check 7 will be what in this case. It means if I'm to convert it, 7 will be 4, 2, 1. It means 4, 2, 1. I'm going to turn everything on, which is 1, 1, 1. However, if we are to consider 1, it means I will check it out for 4, 2, 1. What will it represent? Definitely it will be 0, 0, 1. So putting that together, I will say that 71 in base 8, it's going to be 1, 1, 1, 0, 0, 1 in base 2. So you can confirm. Let's go back to what we have here. 7 is 1, 1, 1, and 1 is 0, 0, 1. So the combination of this and this is what we have here in base 2. I believe this is pretty easy. So let's look at another example. Example 2. In our example 2, we want to convert 2568 to x in base 2. We are asked to find s. Now, I will just go ahead to split this out. And remember, I'm going to use this trick 4, 2, 1, 4, 2, 1, 4, 2, 1, which is representing what we have here. Now, what does that mean? Since we have 2, how can we locate 2 here? It means that this one can be taken, which will turn off 4 and 1. So in this place, the representation will be 0, 1, 0. Let's move over to 5. What can we do? What can we sum up to get 5? It means we can sum up 4 and 1. So we have 1, 0, 1. Since we are not using 2, it will be 0. Let's move over to 6. In 6, what can we sum in here to get 6? It means we can sum in 4 and 2. So since we are going to take 4 and 2, it's going to be turned on. We didn't use 1, so it will be turned off. Let's put this together. It means that 256 in base 8. So that will be 0, 1, 0, 1, 0, 1, 1, 1, 0, 2. So therefore, what is our value of x? Our value of x will be this, okay? So let's quickly consider where we have decimal points, and this will take us to example 3. Here we are asked to convert 1 to the 3 in base 8 to binary. So find x. Now, the first step to do is to bring this out. Remember to put the decimal point, and we know it's in base 8. Just the same way we did the previous one, we are going to put 4, 2, 1, 4, 2, 1, 4, 2, 1, because we want to check the equivalence in binary. So in this case, we are going to check out what will be done to get 1. So it means we already have 1 here. We don't need 4 and 2. So 4 and 2 will be 0, and we have 1. The same thing, does 2 exist here? Yes. So we are going to turn off 4 and 1. So we have 0, 1, 0. Now let's see the other one, 4, 2, 1. Now, what value will give us 3 within this range? It means 2 and 1, when we sum it up, will give us a total of 3. So it means 4 will be excluded. So our 4 will turn off as 0, while 2 and 1 will be 1, 1. Now remember the decimal point. I'm going to put that here. So it means at the end of the day, grouping it, we are going to have 0, 0, 1, 0, 1, 0, dot 0, 1, 1 in base 2. So what is our x? Our x will be 0, 0, 1, 0, 1, 0, dot 0, 1, 1. Okay guys, we've gotten to the end of this video. I hope you understand this conversion trick. Please do well to watch my subsequent videos on number system conversions. And don't forget to hit the subscribe and the like button if you haven't done so. Lastly, if you have any question or anything to suggest, please leave it in the comment section. Okay, so I'll be signing off now. So have a nice time. Bye.